For this set of problems, it says that the probability of breeding a white tiger from two tigers that are not white but have the recessive gene for whiteness is 0.25. And a zoo has bred 30 tigers. So we're asked some information about this, and since the tiger will either turn out to be a white tiger or not, this is a binomial probability situation. So in question 42, it asks for the expected number of white tigers bred. And so I'll use the formula for the mean for a binomial probability, and that's n times p, where n is 30 in this case, and p is 0.25. And so that gives me 7.5. Now in question 43, again, I'm going to use a formula. Now we're using the formula for standard deviation, and that formula is n times p times 1 minus p, and then we take the square root of that result. So this is 30 times 0.25 times 1 minus 0.25. And when I put this into the calculator, I get 2.3717. Now in question 44, I want to find the probability of breeding exactly 9 white tigers. So here I'll use the binom PDF function, and I'm using PDF because it's exactly 9 white tigers. And so I put in the number of tigers in the sample first of all, and the probability, and then we want exactly 9, so 9. And when I calculate this, I get 0.1298. And that's my answer for 44. In 45, we want the probability of breeding more than 10 white tigers. So here, I want the probability that the number bred is more than 10. So I'll say x is greater than 10. And so what we'll have to do in order to figure this out is to take 1 minus the probability that x is less than or equal to 10. That's the opposite. And so I can calculate this using the binom CDF function, because this is a range of values, not just a single individual value. So we have 30.25, and then the upper limit is 10, so I put in 10. And I get 0.1058, rounded to 4 decimal places. In question 46, I want the probability of breeding at most 7 white tigers. So in this case, I want the probability that x is less than or equal to 7. So in order to find this, again, I'll use the binom CDF function, because again, this is a range of values, not just one individual value. And that's 30.25, and then 7 is my upper limit. And so I get 0.5143. Now in 47, it asks us to find the probability of breeding less than 6 white tigers. So we want the probability that x is less than 6, but you have to realize this is the same thing as saying x is less than or equal to 5. So they want the most to be breeded is 5. So we're going to calculate the probability that x is less than or equal to 5, and again we'll use binom CDF. 30 is the number of trials, 0.25 is our probability, and 5 is our upper limit. And so this turns out to be 0.2026. And finally, in 48, we want the probability of breeding at least 5 white tigers. So we want the probability that x is greater than or equal to 5, which is the same thing as saying, 1 minus the probability that x is less than or equal to 4. So we want our upper limit to be 4 here. That will be the opposite. And so we'll do 1 minus binom CDF. 30 is the number of trials, 0.25 is our probability, and 4 is the upper limit. And this gives me 0.9021, rounded to 4 places. And that's how you do those binomial probability problems.